At the end of the year 2025, the city of Dubai possessed the engineering capability to produce roughly 495 million imperial gallons of desalinated water every single day. This is a staggering achievement of modern infrastructure. It is an artificial river summoned directly from the sea, designed to sustain life in one of the most arid environments on the planet. But numbers only tell part of the story. On its thirstiest day of that same year, peak demand across the city reached 487 million imperial gallons. If you look closely at those two figures, the nominal gap between them was just 8 million gallons. That is roughly 1.6% of the total installed capacity on paper. Many analysts might look at that incredibly narrow margin and conclude that Dubai is simply running out of water. They might think the city is on the brink of a catastrophic drought. But that is not the real crisis. The comparison between those two numbers does not reveal Dubai's complete operating reserve, nor does it mean the taps will run dry tomorrow. What it actually reveals is how incredibly fast the city's demand is chasing the very machinery built to contain it. The real crisis does not begin when the city fails to make enough water. The real crisis begins after Dubai successfully makes the water. If clean water is not the real problem, what exactly is accumulating behind it? There is no river flowing through this metropolis. There is no vast freshwater lake hidden beneath the sand. There is no seasonal monsoon to replenish the land. Historically, human settlements have always gathered around natural sources of water. But this city decided to rewrite the fundamental rules of human geography. Instead of finding water, they decided to manufacture it. They built an artificial hydrological cycle using extreme pressure, intense heat, massive steel pipes, and vast amounts of money. The city transformed the hostile, salty waters of the Arabian Gulf into the foundation of a global empire. Every single luxury hotel, every green golf course in the desert, every perfectly chilled shopping mall, and every fountain relies on this mechanical miracle. It is an absolute triumph of human ambition over the harsh realities of nature. The installed capacity grew massively over the decades to approach that incredible 500 million gallon mark. From the air, the massive desalination complexes like Jebel Ali look like the beating industrial heart of the region. They pump lifeblood into a network of pipes that stretches for thousands of kilometers beneath the desert surface. But this profound victory over nature comes with an undeniable physical truth. A desalination plant never produces only fresh water. It always creates a second stream. To understand the hidden cost of this miracle, you have to look at how the water is actually separated. The modern method of choice is a process called reverse osmosis. Imagine forcing an entire ocean against a microscopic molecular wall. The water molecules can pass through this barrier, but only after an immense amount of physical force is applied by high-pressure pumps. But the fundamental laws of physics and the conservation of mass dictate a harsh reality. The membrane does not destroy the salt. It does not magically absorb the minerals. It simply separates them. While the pure, sweet water moves forward into the city pipelines, all the salt, the minerals, and the impurities are trapped and pushed into a leftover stream of water. This membrane acts exactly like a molecular doorway. It allows the water to pass through and enter the bright, luxurious apartments of the city. But it leaves the physical receipt of that transaction behind. The water passes, the salt remains, the city grows, the machine grows with it. And once you follow that second stream, Dubai's water miracle begins to look less like a permanent solution and much more like a massive loan. This brings us to the first massive obligation, which we can call the capacity debt. Total desalinated water demand in 2025 reached an astronomical 161 billion imperial gallons. That represented a jump of over 6.6% compared to the previous year. The peak demand surged from 487 million gallons in a very short time. This surge is not just driven by residents washing their cars or taking longer showers. It is heavily driven by a booming economic engine that cannot afford a single moment of hesitation. Consider the tourism sector. Dubai welcomes millions of international visitors every single year, with massive influxes during the peak winter months. Every new luxury resort built on an artificial island requires millions of gallons just to operate its cooling systems, its infinity pools, and its lavish bathrooms. A sudden spike in tourist arrivals creates a hidden tourism crisis for the infrastructure. The city must guarantee absolutely flawless water delivery to maintain its reputation as a premier global destination. If a major resort experiences a water pressure drop, the illusion of limitless luxury shatters instantly. Therefore, the city is trapped in a relentless loop of expansion. The city develops further to attract more people and businesses. This creates a higher peak demand. The government must then build new desalination capacity before that demand hits the absolute limit. The new capacity provides a safety net that encourages even more development, and that new development instantly requires more capacity to be planned and built. More capacity enables more growth. More growth demands more capacity. The solution becomes the exact reason the next solution is ultimately required. The comparison of 495 against 487 does not mean the city is entirely out of water today. It reveals the terrifying speed at which human ambition consumes technological progress. Because demand never sleeps, the infrastructure must constantly expand. This introduces the second profound obligation, which is the capital lock-in. To stay ahead of the thirst, Dubai launched the Hassyan reverse osmosis project. This facility alone is designed to add 180 million imperial gallons of capacity per day. The publicly announced investment for this single massive project was around 3.37 billion dirhams. Operating under an independent water producer model, the plant is expected to be fully completed by the first quarter of 2027. The financial engineering behind this project is almost as impressive as the mechanical engineering. The reported bid for the water tariff was astonishingly low, at roughly 36 cents in US currency per cubic meter. On paper, the water looks incredibly cheap, but this creates a profound paradox. The water is only cheap on a per cubic meter basis because the machine producing it is absolutely enormous. And the machine is absolutely enormous because Dubai can never afford to become thirsty. The city is committing billions of dirhams to infrastructure that must be maintained, upgraded, and operated for decades. This is not necessarily public financial debt in a traditional accounting sense. It is a long-term technological obligation. It is an infrastructure lock-in that binds the economic future of the city to the continuous operation of highly complex industrial facilities. But capital and money are not the largest debts incurred by this system. The largest debt does not remain on the land. Take a moment and look at a glass of water poured from a tap in a high-rise apartment. It is perfectly clear. It is safe. It is entirely disconnected from its turbulent origin. Now, let your mind travel backward against the current of that water. Follow it down the pipes inside the walls of the skyscraper. Trace it through the underground distribution network beneath the hot asphalt. Move past the massive inland storage reservoirs. Go all the way back into the deafening noise of the reverse osmosis plant. Pass backward through the violently vibrating membranes. And there, you will find the separation point. While your clean water went toward the city, the rest of the liquid was pushed in the opposite direction. Global studies from 2019 estimated that the world produces about 95 million cubic meters of desalinated water every day. But at the same time, the global industry generates roughly 142 million cubic meters of concentrated brine. No, this does not mean Dubai produces exactly 1.5 glasses of brine for every single glass of fresh water. That would require very specific plant recovery data to verify. But it reveals the ultimate rule that desalination simply cannot escape. Fresh water is only one side of the output. The rest flows back out through massive discharge pipes. It travels away from the gleaming city skyline, and it sinks quietly to the bottom of the sea. This brings us to the ecological debt. When the concentrated brine leaves the plant, it is significantly denser and heavier than the normal seawater around it. Because it is heavy, it does not easily mix with the surface water. If it is not diffused perfectly through highly engineered underwater structures, it sinks directly to the seabed. It creeps along the ocean floor like a thick, heavy, invisible river. This creates localized zones of extremely high salinity. It can lower the dissolved oxygen levels that marine life desperately needs to survive. It places severe stress on benthic organisms, the creatures that live on the ocean floor and form the foundation of the marine food web. Now, we must be very careful not to exaggerate this into a sensational apocalypse. Some might claim that Dubai is turning the entire Arabian Gulf into a dead salt lake. That is an extreme overstatement. Recent modeling suggests that natural circulation and water exchange through the Strait of Hormuz can help limit total salt accumulation across the entire Gulf basin under current conditions. The Gulf is vast, and its natural currents have a massive capacity to dilute. But the credible threat is highly localized. The stress occurs along the shallow coastal areas. It happens near the specific discharge points where the chemical makeup, the temperature, and the salinity of the water are radically altered. The Gulf can certainly move the salt over time. It just cannot make the salt cease to exist, and this creates a terrifying realization. The sea does not merely receive the industrial waste of the city. It is also the exact same raw material that Dubai must pull back into the machine tomorrow. When the sea becomes more complex, the machine must work harder. This is the fourth debt, the burden of energy, chemicals, and maintenance. If the intake water from the Gulf contains higher salinity, the osmotic pressure inherently increases. The high-pressure pumps must consume significantly more electrical energy to force the water through the membranes. But salinity is not the only challenge lurking in the shallow waters of the Gulf. The intake water often suffers from very high and fluctuating temperatures. It contains turbidity, microscopic algae, organic matter, and various marine organisms. All of these factors require aggressive pre-treatment before the water even touches the delicate reverse osmosis membranes. If the water quality drops, the plant operators must use more chemicals to clean the incoming water. The membranes suffer from increased fouling and scaling. They require more frequent chemical cleaning cycles to restore their efficiency. The physical lifespan of the equipment degrades faster. The maintenance costs rise steadily. The mechanism of this feedback loop is absolutely real and undeniable in the engineering world. Proving that Dubai's own discharge has permanently ruined its own intake at Jebel Ali would require specific local intake records and discharge modeling that are tightly guarded. But the fundamental law remains intact. A city cannot treat the ocean as an infinite dumping ground and an infinite supply well simultaneously without eventually paying a massive penalty in energy and maintenance. The more difficult the water becomes to process, the more aggressive the industrial response must be. This increases the operational cost, which in turn demands a larger and more complex system to maintain the output. All of these intersecting obligations lead to the final and most terrifying debt of all. It is the absolute burden of operational dependency. A desalination network is not like a natural river that flows continuously driven by gravity. It is an intensely fragile, highly choreographed industrial ballet. It relies continuously on an unbroken supply of electricity. It needs massive pumps to function flawlessly. It requires a constant delivery of chemical supplies and replacement membranes. It demands extensive human expertise to monitor the intake structures and the distribution networks. The government has invested heavily in strategic reserves, like the Aquifer Storage and Recovery Project, designed to hold billions of gallons to supply emergency water for up to 90 days. This is a brilliant engineering safeguard, but it is only an emergency buffer, not a permanent substitute for daily production. Imagine a severe stress scenario during the peak heat of the summer months. Imagine a situation where peak demand is astronomical due to a tourism boom. Simultaneously, a localized red tide of algae severely compromises the water quality at a major intake pipe. A few units must be taken offline for emergency cleaning or scheduled maintenance. The operating reserve rapidly shrinks, forcing the storage system to bleed its reserves into the network to keep the pressure stable. The terrifying part of this scenario is not that the system has already failed. The truly terrifying part is the realization that the system is simply too essential to ever be allowed to fail. A massive dry metropolis like Dubai does not just build residential towers and multi-lane highways. It is forced to build and sustain its very own artificial hydrological cycle. And that cycle exists entirely at the mercy of continuous energy flow and flawless industrial management. Of course, the engineers and planners managing this vast network are not ignoring these challenges. They are actively deploying the most advanced technologies in the world to fight back against this mounting debt. Dubai has been systematically shifting away from older, energy-hungry thermal desalination methods toward more efficient reverse osmosis. Reverse osmosis generally consumes significantly less energy per cubic meter of water produced. Projects like Hassyan are being designed to integrate with clean, renewable energy sources, which helps lower the carbon footprint of the water produced. The government is aggressively expanding total installed capacity. They are strengthening the underground aquifer storage to build thicker layers of resilience. There are ongoing efforts to maximize the reuse of treated wastewater for irrigation, reducing the burden on the primary desalination plants. Advancements in intake technology, chemical pre-treatment, and energy recovery devices are constantly pushing the efficiency of the plants to new limits. These are all highly commendable and incredibly sophisticated engineering achievements. But while these innovations are impressive, they do not magically erase the fundamental truths of the system. They may drastically reduce the energy required per unit, and they may lower the financial cost of operation. But highly efficient reverse osmosis still produces concentrated brine. Better energy recovery does not stop the membranes from requiring chemical cleaning, and most importantly, higher operational efficiency does not guarantee that total demand will stop growing. If the population continues to expand, and the tourism industry continues to demand more luxury, the entire massive system must simply grow larger. Dubai may very well be winning the daily battle over the cost and efficiency of each individual cubic meter of water, but the much larger, existential question is whether the city can ever stop the total number of cubic meters from growing forever. There is one more invisible layer to this debt that is being quietly written by the changing global climate. As global temperatures continue to rise, the summer heat in the Arabian Gulf becomes even more extreme and prolonged. This intense heat drives residents, businesses, and luxury resorts to consume vastly more water and electricity just to maintain a baseline of comfort. To meet this sudden spiking demand, the power stations and desalination complexes must run at their absolute maximum limit. But running at maximum capacity inherently requires drawing in more seawater and simultaneously discharging more warm, concentrated brine back into the ocean. The Arabian Gulf is already one of the warmest bodies of marine water on the entire planet. When industrial facilities constantly dump concentrated brine and thermal waste into a warming shallow sea, they inevitably alter its local physical properties. Warmer seawater naturally holds significantly less dissolved oxygen than cooler water. It also drastically accelerates the rapid growth of certain algae, plankton, and microscopic marine organisms. This biological explosion brings the problem right back to the intake pipes of the city. When the intake water becomes unnaturally warm and highly biologically active, the delicate reverse osmosis membranes face a severely elevated risk of biological fouling. The pre-treatment facilities must work much harder and consume more chemical agents to clean the water before it can even touch the filters. The system requires more energy and more frequent maintenance cycles to handle this biologically stressed water. This dynamic creates the ultimate ecological paradox for a desert megacity. The city uses the sea to cool itself down and quench its thirst during the brutally harsh summers. But the industrial process of surviving the heat contributes to warming and stressing the very marine environment it relies on for survival. The advanced technology allows humans to temporarily adapt to extreme climate conditions. Yet the massive operational footprint of that exact same technology makes the local coastal environment slightly more hostile and complicated every single year. It is a perfectly closed loop of survival and environmental stress. The machine protects the fragile city from the unforgiving desert, but absolutely nothing protects the sea from the relentless demands of the machine. Dubai has unequivocally proved that endless capital and brilliant engineering can forcefully extract fresh water from a hostile sea. It has built an oasis of glass and steel that defies the natural boundaries of the desert. But the microscopic membrane spinning inside those massive pressure vessels performs no actual miracle. It does not destroy the salt. It does not erase the vast amounts of energy consumed. It does not cancel the relentless need for maintenance. And it certainly does not end the city's endless thirst for growth. The machinery simply separates the clear water that Dubai desperately wants from the heavy, complex debt that it would rather not see. It is a geographical illusion sustained by extreme technology. Above the surface, in the bright sunlight, the tap keeps running flawlessly in every hotel and apartment. But deep below the surface, in the dark waters of the Gulf, the massive bill for all that luxury keeps quietly sinking to the bottom. Dubai did not defeat scarcity. It turned scarcity into a machine, and it committed itself to keeping that machine alive forever. Most people who visit or live in this city see only the pristine glass of water placed on their table. Now you can see the intense pressure, the massive power generation, the delicate molecular membrane, and the invisible, heavy river flowing in the exact opposite direction. If you value investigations that follow a technological miracle all the way down to its hidden ecological and operational costs, hit the subscribe button. Because the most important part of a global megacity is very often the part that is carefully designed to remain completely out of sight. The concept of a desalination debt discussed in this video is an analytical framework used to describe operational obligations. It is not an official financial term or a declared accounting liability on the balance sheets of any local utility authority. This analysis distinguishes between verified operational data, logical systemic inferences, and hypothetical stress scenarios. We do not claim that Dubai is currently lacking water, nor do we suggest that its water infrastructure has failed. All data points referenced were accurate based on available projections leading into 2025 and should be cross-referenced with current utility reports. The primary purpose of this investigation is to explore the long-term limits, the ecological realities, and the systemic costs of relying entirely on artificial water infrastructure.